All right, here we go. Chapter 8. Our objective is to describe how mountains are formed, identify different types of mountains, and locate major mountain ranges on a map. So here we go. Make sure that you are following along as I read. Our big question is, how do movements and forces of tectonic plates build mountains? And our first vocabulary word is sea level, which is the average height of the ocean's surface. So the top of the ocean, that is sea level. All right. Make sure you follow along as I read. Okay. Page 72. The year was 1953. Mountain climbers Edmund Hillary and Tenzing Norgay stood on the hard-packed snow. They gasped for breath in the thin air. Their faces burned from the bitter cold wind. Despite this, they were grinning from ear to ear. Hillary and Norgay had just made it to the top of Mount Everest. They were the first people to reach Earth's highest point, 20,029 feet above sea level. Ooh, that would be quite an accomplishment. Mountains are some of Earth's most awe-inspiring features. In 1953, geologists were still searching for answers as to how mountains form. By the 1960s, scientific evidence pointed to plate tectonics as a driving force behind mountain building. As you read in Chapter 2, our planet's rocky exterior isn't one solid piece. It is broken up into the collection of gigantic tectonic plates. Earth's tectonic plates move slowly, but their movements have dramatically changed Earth's features over time. Plate movements have shuffled Earth's continents into different positions. They have destroyed old oceans and created new ones. They have also built mountains and mountain ranges in several ways. What text evidence supports the idea that plate tectonics are important in the creation of mountains? Well, I hope you can see in the last paragraph on page 73, where it says plate movements have shuffled Earth's continents into different positions. They have destroyed old oceans and created new ones. They have also built mountains and mountain ranges in several different ways. That is evidence in the text that plate tectonics are important in the creation of mountains. All right, we're going to move on to page 74 and 75. Some of the Earth's highest mountain ranges formed as sections of continental crust collided over millions of years. The collision that formed Mount Everest is a good example. Everest is part of the Himalayas, a vast towering mountain range between India and China. The Himalayas formed when continents on two tectonic plates met head-on. We will, in a little while, find India on a map. It lies at the southern end of Asia. India wasn't always where it is today. Hundreds of millions of years ago, India was an island. It sat out in the middle of the Indo-Australian plate. It was separated from Asia, which sits on the Eurasian plate by an ancient ocean called the Tethys Sea. The Indo-Australian plate began creeping northward about 200 million years ago, driven by moving magma in the mantle below. It slowly collided with the Eurasian plate, where the two plates met. Subduction took place. The heavier oceanic crust of the Indo-Australian plate slid under the lighter continental crust of the Eurasian plate. And you can see by that diagram that the Indo-Australian plate moved slowly northward, carrying India along with it. As the Indo-Australian plate kept moving northward, India was carried along. It inched closer and closer to Asia. The Tethys Sea began to disappear. India finally collided with Asia around 40 million years ago. India's rocky continental crust pressed directly against Asia's continental crust. As the two large land masses continued to push harder and harder together, the continental crust began to crumple, and enormous pressure created by the moving tectonic plate caused the rocky crust to heave upward. Great masses of rock gradually rose up into a series of enormous folds, and the Himalayas were born, the Himalayan mountains. More and more rocks were uplifted as the Indo-Australian plate kept moving. The Himalayas rose higher and higher. In fact, they are still rising. They are growing taller at about the same rate that your fingernails grow. Geologists classify the Himalayas as fold mountains. The name refers to the way rocks are pushed up into huge folds by moving tectonic plates. The Alps, Europe's highest mountains, are fold mountains that formed much like the Himalayas. The Appalachians in North America and the Urals in Russia also formed through collisions on continental crusts. All right, so in which direction did the Indo-Australian plate move? If you look back, it moved north. And then what would happen if the plates had moved some other direction? If it had gone a different direction, the Himalayas probably would not have formed. Asia would not include India. And the map of today would look very different. So when it talks about the fold mountains, and we'll learn a little bit more in just a minute, but the tectonic plates collide, pushing the continental crust together with so much pressure that it crumples and it gets pushed up, creating folds. So you can do that with your hands too, push them and create mountains, folds like that. That's how fold mountains. All right, so we're going to move on to page 76. Like many other fold mountains, the Himalayas contain quite a bit of sedimentary rock. Why? In the case of the Himalayas, it started with the Tethys Sea. For millions of years, erosion washed sediments from Asia and the ancient island of India into the Tethys Sea. Countless layers of sediments, along with remains of ocean animals, were deposited on the seafloor. Over time, pressure and heat helped turn these sediments into sedimentary rocks. As plate movements slowly brought India and Asia together, some of the seafloor's sedimentary rocks were pushed up. Heat and pressure from the colliding plates transformed some of them into metamorphic rocks. Other sedimentary rocks remained relatively unchanged. This is how fossils of ancient ocean animals ended up on top of Mount Everest. So that's interesting. We've talked about how fish fossils might be on the top of a mountain if the ocean had been up there. But this is interesting because the rocks had been down there and then they were pushed up. So it had been under the ocean here and then pushed upwards. And now the rocks that were under the ocean were up here. Fossils at the top of the world. Trilobites and crinoids are two of the most common types of fossils. And those are the ones that are at the bottom. These are crinoids and trilobites. I don't see any trilobites. Oh, here are the trilobites. Sorry, it's hard to get them. Those. Trilobites were hard-shelled ocean animals related to modern-day crabs and lobsters. Trilobites lived at the bottom of Earth's ancient oceans, including the Tethys Sea. Crinoids were animals too, but they looked more like plants. Trilobites and most crinoids became extinct about 250 million years ago. A few types of crinoids still survive far below the ocean's surface. So, that is where we're going to pause and have you answer 3 of the questions, and then you will come back and resume and listen to the rest and read along, and then you will answer the last 3 questions. Right, we are back. And we are going to read page 77. Folding at the edges. Along South America's western coast, the oceanic Nazca Plate has been sliding under the South American plate for millions of years. This has caused massive folds of rock to pile up along the edge of the continent. These folds are now the Andes Mountains, the longest mountain range on land. As you read in chapter 4, the edge of the subducting plate melts as it descends into Earth's hot mantle. The resulting magma moves up through the cracks in the Earth. It may erupt on the surface to form volcanoes. The edge of the Nazca Plate is melting as it slides beneath the South America Plate. Erupting magma has created many volcanoes in the Andes mountain range. So we know that the fold mountains contain quite a bit of sedimentary rock, and they look like folds of rock. And we know that the Andes Mountains in South America are also fold mountains. Okay. It's page 78. Faults and blocks. The longest, highest mountain ranges on land are mostly fold mountains. However, moving tectonic plates build mountains in other ways. Fault block mountains form when gigantic blocks of rock move up and down along fault mountains. At some faults, such as the San Andreas Fault in California, blocks of rock move horizontally past each other. That, as you can see in the picture, as they slip. At other faults, slips cause blocks of rock on one side of the fault to move up. These slips also cause blocks on the other side of the fault to move down. Repeatedly, slips gradually force these rock blocks higher and lower to cause fault block mountain ranges. Oh, if you look at the picture on page 79, you can really see that. The Grand Teton Mountains in Wyoming are fault block mountains. That's interesting. Fault block mountains, back on 78, third paragraph, typically have one steep side, really steep. This is sloping, this is steep. And one sloping side. The steep side forms a high sheer cliff where it just like cuts right off. Germany's Harz Mountains are one example of fault block mountains. Others include the Grand Tetons in Wyoming and the Basin and Range Province of Utah, Nevada, and Arizona. On to page 80. I want you to stop a little bit before we read page 80 and think about how these fault block mountains are formed. I think that's so neat how, the giant blocks of rocks move up and down along faults and cause those mountains. Okay. If we can think, how are fold mountains and fault block mountains similar and how are they different? They're both formed along tectonic plate boundaries. They're both part of long mountain ranges. They are different because fold mountains form when tectonic plates collide and pressure crumples the crust, pushing the crust upward, creating folds. In contrast, fault block mountains are formed when gigantic blocks of rock move up and down along faults, slipping past each other, leaving rocks on one side very high and the other side very low. Okay, we are going to move on to Under the Dome, which is page 80. Most people think of sharp, jagged peaks when they hear the word mountains. Dome mountains are quite different. Dome mountains look like giant humps of rock with rounded tops. They usually occur as isolated mountains on otherwise flat plains. Some dome mountains form when magma pushes upward onto the Earth's crust from the mantle. The magma cools into igneous rock before reaching the surface. This huge lump of igneous rock causes the crust above it to bulge like a blister on skin. Utah's Navajo Mountain is a good example of a dome mountain that formed this way. According to the text, how are dome mountains formed? That is really neat, that the magma, builds up, but that it cools. And so you've got this hard igneous rock under that, and it makes a huge bulge under the land, like a blister on the skin. Wow. Dome mountains don't have sharp, jagged peaks, and they're usually just isolated. It's not like on a long range of mountains. Okay, mountains on the prairie. Page 81. You can see the Black Hills of western South Dakota from a long way off. These dome mountains rise up from the surrounding grassy plains as dark, hunched shapes. They are the highest mountains east of the Rocky Mountains. Very ancient granite forms the core of the Black Hills. Millions of years of weathering and erosion have exposed this igneous rock in many places. The sculptor Gutzon Borglum made one tall granite formation in the Black Hills famous. He carved the faces of 4 presidents into the rock to create Mount Rushmore National Memorial. Another sculpture in the Black Hills has also gained attention as the world's largest sculpture in progress. Crazy Horse Memorial honors North American Indian heritage and depicts the face of the Sioux leader Crazy Horse, started in 1948 by sculptor Korczak Zalewski. Work on the massive sculpture still continues today. So, remember, dome mountains have rounded tops, where fault block mountains have steep, tall peaks. Dome mountains are usually isolated, whereas fault block mountains are part of a continuous mountain chain. So the different interactions of tectonic plates build different types of mountains. Fold mountains are built when the plates collide together at their boundaries, or if a plate with ocean crust subducts beneath the plate with continental drift, they crumple up. Fault block mountains are built when blocks of rock move up and down along faults, which are usually located at plate boundaries. Dome mountains are built when the magma beneath the surface pushes up into the crust. Volcanoes, most of which form along tectonic plate boundaries, also build mountains as they erupt. Our Earth is amazing. All right, now you can stop and answer the rest of the questions.